As you may know, during last years there has been a huge development towards digitalization and what is known as the digital thread. This new trend appears as the result of companies wanting to trace the status of a given product from the earliest concepts through engineering, manufacturing, and even into the field. So by collecting information at every step of the process, they try to get closer to achieving their product success. Digital thread is usually represented as shown here, but this standard picture of the digital thread is quite incomplete, as there are many other stakeholders that haven't been represented here, and we found that every group in the company are important to the product success, and should be just as connected in the flow of data and information as traditional product development teams. We know this because many of our traditional hardware development companies are starting to look more and more like software companies, and we've been working to discover what is the best way to get the most of all this digital transformation process. So we can find examples of this behavior where OEMs converge with IoT softwares everywhere. We have smart buildings that are designed to allow the user to control lighting systems, air conditioning, manage occupancy control, and 1,000 other things. In industry, both in terms of machines and raw materials, there has been a great change towards automation, and robotics are taking an important place in the manufacturing sector. We also have consumer electronics. I'm sure all of us have at home at least one connected device with an application so that we can control them from anywhere. The energy sector is also a great example. Here, there has been a great development, and today these companies have predictive maintenance systems thanks to simulation and analysis, and all this allows them to continuously improve and to be able to recover after a critical situation, improving their product's life cycle. Another good example are smart fleets. They are not only in the industry sector. We also see them on the streets, where sharing companies are growing, offering services like electrical motorcycles, cars, and even scooters. So if we take a look at all these examples, we can see that the products are still the same. We are just using the information we get from them to get powerful insights. So after analyzing all these different companies' behavior, we arrive to the conclusion that if we are collecting this huge amount of data and information, why not include all the teams in the company to this workflow? Because companies are not looking to accelerate the digital thread. What companies are looking for is to accelerate the digital enterprise. And that is something that affects every team in the company. So for doing that, we need to include in the picture software development, marketing, and sales, who need to be connected to the research and development process as much as manufacturing or services. It should even include finance, operations, and human resources, because stakeholders across the entire enterprise need access to data, especially the underlying cross-functional data that allows for true insight. The thing is that we have also seen that there are some serious growing pains for organizations who start this transformation. So to ease the process at our customers, we have developed a new tool for IoT. SmartWorks IoT is a cloud-native low-code platform focused on helping manufacturing, software development, and engineering teams to connect with their assets in the field and build the automation and applications needed to monitor, analyze, and control them. SmartWorks IoT is the result of starting to think about the future of product development so that we can offer our customers the tools they need when they need them. It has meant that we have evolved from beyond product development, from tools that offer generative design, topology, and mechanical or electrical simulation, to smart product development, which rounds out the offering with tools for embedded development, software development, and continuous improvement. So to understand all this better, let's see some more examples. And that is quite easy, as smart products are now mainstream. We have watches that can track our health. Our refrigerators even allow us to order stuff when we run out of them. And we have light bulbs that connect with an application so that we can manage them remotely and analyze the data to figure out ways to save energy. For large industries, the value of smart product development is also powerful. Manufacturing equipments can tell us when they need service, and we can develop predictive maintenance process. Quality can also be improved at the production lines with smart products. And thanks to monitoring and controlling the data from field equipment can help companies to improve operational and design decisions. All these examples of smart products are based on IoT. So whenever any of these companies decides to go a step forward and provide not only the lighting bulbs, for example, but also the application to control them, they will realize that the IoT ecosystem they need to manage to control all this is quite complex. And what they thought it was going to be an easy process of developing an app for the end user, which is the front end, has turned into a complex problem, because edge development, DevOps, and backend architecture have to be designed too. Edge development will enable them to manage devices in the field and process the data gathered from them so that we can control the lighting systems remotely, for example, and know which ones are on and which ones are off. Development and operations will ensure that all these services needed are up and running 24/7 and, if necessary, scale to meet demand, all with security standards. Backend development will help them orchestrate all interactions between devices, users, and the logic required for the product itself, so that every user has just access to their data and can control just their own devices. At this point, we have been talking about multiple examples, but let's focus on the following one to understand better how are we helping our clients with SmartWorks IoT. So from now on, let's imagine we are starting a company to sell electric trucks, and we want to go a step forward and sell not just the truck, but also a service so that our end users, the drivers and the companies, can control, monitor, and perform analysis on their trucks and know their status in real time. When we start the product concept design, we will be testing just one truck, and we can easily implement a device to control all the parameters we want and send all this data to a computer. But once we get to face a real use case, we will realize that the connection with our computer is going to fail. And if we scale and end up testing not just one truck, but a whole fleet, this flow is not going to work, as the device that we have designed before is not useful anymore, and same with the method for sending data to our computer, which is not going to support all this amount of data. So let's go back a little bit to understand what is the process that we should have followed. First of all, we need to understand how can we manage our fleet. We need to start first with the asset, with the truck, and we need to start understanding what we want to do with it. And that is to send data from the truck to the cloud, and then be able to send back information from the cloud to the truck. But also to do this if I scale and end up having a fleet of trucks. On top of receiving and sending data, the cloud also helps us achieve different things. We can secure our data, we are able to automate processes, to run predictive models, and we can also store all the data for a long time. When we have all the data and business logic in one place, we can start to do different things, such as understanding how the product behaves, using a dashboarding tool to access all that data, and start to make sense of it. Although dashboarding tools can provide a lot of value, they are not the tool that your customers expect when they are operating your connected truck. What they expect is an application that they can share with their employees to improve their overall operations. The development of this application can be easily executed leveraging all the data, all the automation, and all the access control that is built in our cloud. And once you've gotten the hang of building an application for your smart connected product, there are endless possibilities of the different applications that you can create to help the different users that use on a daily basis your product. It can be an application for the driver to understand what routes they need to do, to be able to send a maintenance work order, confirm that the delivery was made, and even ask for a vacation day next Saturday. So to manage all these things that we've been talking about, as the database, the backend, the user directory, the dashboarding tool, we have SmartWorks IoT. SmartWorks IoT is a low-code development platform that allows for designing IoT applications. So thanks to it, the development process that we have been explaining is simplified, while reducing costs and risks when developing a smart product. What SmartWorks IoT offers are the different services that are common to all digital products and that allow to develop both the backend and the frontend and scale using different technologies. So we provide the database, a bidirectional communication system, a way to manage access control, a dashboarding tool, and many other services. So all these necessary microservices are already integrated with each other, and there are even some processes that we have automated inside SmartWorks IoT. This ensures that the frontend remains completely under the control of the client, which is why they really want to control. They don't really care about how the database is built, how the data is being collected from the different trucks, or how the management of the fleet is being done. They just want to be able to design the application their users are going to be using and to have a flexible environment that adapts to their smart product and eases the work to their development team. So to sum up, SmartWorks will act as the linking piece between all your devices, the trucks, and your end users, as it manages the device connectivity, data storage, allows for business logic implementation, and to restrict access control. So once the use case scales, and we end up having so many trucks to control, we will also want to control our fleet of trucks and visualize the data we've been storing in SmartWorks to analyze it in real time and be able to draw relevant conclusions. So for doing that, we have Panopticon, which is another Altair tool integrated with SmartWorks IoT to design powerful dashboards easily without having to write a single line of code. And finally, if we need to rely on heavy computing and the edge so that we are able, for example, to deploy complex machine learning models, we can also use SmartWorks to help with the deployment and manage all this code at the edge. Now that we have briefly gone over everything we are trying to achieve, let's move on to see SmartWorks IoT in action. In this demo, we will set up in the platform everything we need as the trucks company to develop the application for our end users, as well as the dashboard, so that we can also perform analysis over the whole fleet of trucks. And for doing that, first thing we need to do is to create an account in SmartWorks IoT. Just search for swx.altair1.com. Fill in the form and choose to start your free trial. You will receive an activation email, so just confirm the link and log in to your new account. First thing we need to do is to create a space for our project to live in. Spaces are isolated work environments to build our different smart product projects. Every space will be sandboxed, and therefore it cannot access the resources from different spaces. So let's create a new space by clicking over here. Note that for security purposes, the space ID must be unique for the whole platform. So for example, if we try something like test and click on create, you will discover that someone is already using that ID. So let's choose a better space ID for our project. Note that the ID length should be between 3 to 26 lowercase and alphanumeric characters only. A space ID cannot be changed once we click on create, but what we can change is the space name, which is the one that is going to be displaying as the title of your project. You can also change the color so that if you end up having multiple spaces, you are able to recognize them easily. So once we have everything defined, let's click on create. Next thing we need to do is to start defining our IoT ecosystem. This left side menu have the different sections that we are going to be covering in this tutorial to create our tracks project. From here, you can easily contact support in case you have any questions or issues using the platform. Here is the documentation link. From here, you can see what are the new features that we are launching, access the SmartWorks IoT tutorials, and also access the developers documentation. From here, you can easily log out. By clicking here, you can collapse the left side menu so that you have more space when working on a specific section. If you want to go back to the space picker section, just click over here. But let's go back to our space. If at any point you want to change the space name or the space color, you can click on Space Settings, General, and modify them from here. Also, if you are not going to use a space anymore, you can delete it from here. So first section that we are going to be working on is AnythingDB. So AnythingDB is a database designed to store anything from our connected product. So to start to define our database, we have what we call things. They are going to represent the different entities in our world. They can store information about real-world objects like our trucks, companies, or users, as well as information about concepts like work orders or processes. Things are defined based on a standard schema definition compliant with Web of Things. Web of Things describes a set of standards by the W3C for the interoperability of different IoT platforms and application domains. One of the key components specified by the Web of Things building is the thing description. A thing description describes a virtual or a physical device, the things, expressed in JSON formatting, and based on this is how we define our things schemas. So thing descriptions have three main attributes to model the devices. So first thing we have are properties. They describe the attributes of our things. So for example, when defining our trucks, we can set properties for store the information about the battery remaining, the kilometers driven, or the owner of the truck. Then we have actions that define how we can interact with our thing. So for example, we can define an action to switch the lights of our truck or to control the AC system. And finally, we also have events that standardizes the messages received from our device. So for example, we can set up an event when the battery is below a certain value or when the tire pressure is low. So with this structure in mind, we can start to define the different entities in our IoT ecosystem, our different users, different companies, or the different trucks. And once we have all the entities defined, we can structure our database in a way so that we can group the information into different tables called collections. So all trucks, users, and companies information will be managed under the same collection. And we can even add links to establish relationships between things or external resources. So for example, we can add a link to establish a relationship between a truck and the user. To ease this creation process, we can use models, which are templates so that the creation of identical things can be done faster and easier. So once we have the database structure defined, bidirectional communication can be done between our devices and the database using HTTP or MQTT protocol, and the unique credentials for each device will be generated inside the platform. Also, communication between the database and the web or mobile application can be done similarly. Note that to ease all this communication process, SmartWorks IoT has its own MQTT broker, API gateway, and is able to manage database backups and eases the process to autoscaling. So let's go back to the platform to see how all this is done. So to visualize everything better, let's collapse the left side menu. Also by clicking here, we can disable this option so that we have more space. So first thing we need to do is to create a collection. To model our IoT ecosystem, we are going to create a collection to store the information about the different companies, another one to store the information about the different users, and one last collection to store the information about the trucks. Note that there are some restrictions regarding the collection's name. It requires 2 characters minimum, and no spaces or special characters are allowed. And let's create one last collection to test first some things. So once we have the collection created, what we need to do is to start adding the different things. So for add a new thing, just go over here and click on New Thing. As you can see, there are different options to add a new thing. The easiest one is to enter a title and click on Create. So once we click on Create, this panel appears. So from here, we can easily start to add the different properties, actions, events, and links. So just by clicking here, we can start typing the property key and choose its type. We can even enter an initial value, and there are some optional descriptors. So for example, we can enter a title, we can add a description, or we can add units. Let's click on Create. Similarly, if we want to add a new action, just go over here and click on the plus symbol. Enter the key, a title and a description can also be added. Let's also add an event. Note that there are also some restrictions when adding a new action, event, or property. And let's define a link. So if we want, for example, to change this property, just go over here and click on Edit. So from here, we can change the property name, the type, and see how, for example, when we choose the number option, we can enter a property data validation. So for example, we can set a minimum value and a maximum value. And we can add some units. And similarly, we can keep on editing the properties, the events, and the links. Note that when we click on a link, we are redirected to the results that we are pointing to. So from each one of the things that we create, the platform automatically generates its unique ID. And also, if you click over here, you can see that while we were entering these properties, actions, events, and links, the schema following the JSON formatting has been written here. Another option that we can follow to add a new thing is to directly enter this schema. So if we choose to skip to schema, you see that there's a template for the schema predefined. So for example, if we search on the Web of Things for a thing description template like this one, and we paste it over SmartWorks, and click on Save, we will have automatically created this new thing with the properties, actions, and events that were listed on the thing description. If you want to start understanding how does the API works in SmartWorks IoT, you can try the API Inspector by clicking over here to display the utility belt and choose API Inspector. If you access the developer's documentation, you can search for what you want to do. So for example, let's add a thing description. If you click here to try it out, you can enter your own values so that you will have the exact request that you need to do. So this should be the request URL. This is the information that we need to be sending as payload. And let's choose to make a post. The API inspector already provides the token needed from your studio session to access this request. So let's click on send. And if we refresh, we will have the new thing created with all the properties, actions, and events. As we won't be using this collection anymore, we can delete it. So first thing we need to do to delete a collection is to delete the things inside that collection. And once we've done that, let's go to the settings and choose to delete the collection. So let's start filling the information for the different collections. For the companies, we are going to start by creating a thing that is going to be storing the information of each one of the companies that are our clients. So this thing schema will be quite simple, as we just want to add some properties. So for example, we enter the name of the company, the number of trucks that they have, and the number of drivers that they have. As we may want to be adding more companies on and on, we are going to set this thing description as a template. So for doing that, we just have to go over here and click on Save as Model and enter a name for our new model. Click on Add and save it. So now, if we choose to add a new thing to this collection, we can just go over here and choose to apply the model that we have just created. And if we move on to the model section, we will see that here is our model created. If we click on View It, we can view the schema, but also we can create a new version if we want to update some information. So for example, we can decide to add an event so that the company knows when the trucks need some maintenance. If we click on Save, then we have the second version of our schema created. And if we go back to the Things pane, we can upload these two things to this new model by selecting them and clicking over Edit, Model, choose the model to apply, and choose the new version. Click on Update, and if we open one of these things, you will see that they have already the event added. So let's move on to the users collection to start filling it. In this case, we are going to choose to first create the model. So for doing that, let's go to the Models pane and click on New Model. Name the model and click on Create. See how a similar pane to the things is displayed. So let's start by adding the thing title and the different properties. Once we have the model created, we can start at the different users that are going to represent the different drivers that have our trucks. So just click on New Thing and choose to add this model. Let's see one last way to add things to a collection. So let's move to the trucks collection, and when clicking to add a new thing, let's choose to skip to schema. So if by any chance you already have your schema defined in JSON formatting, you can go over here and paste it. Click on Save, and that way we can also create a theme. So now that we have all our collections created with some things defined, let's see how we can send some data to SmartWorks IoT. So if you remember, before we mentioned that we have two methods to communicate with our platform. First one is HTTP, which is the protocol used to transfer data over the web, and it uses a server-client model. So our devices will be the clients sending requests using the different HTTP methods to the server that will generate the response and communicate it to the mobile or web application or to the devices if needed. So the IoT management platforms that use it have an application interface, API, based on HTTP that uses the well-known HTTP methods to read, create, delete, and update the information. But you can also send data using MQTT, which allows for messaging between device to cloud and cloud to device. This protocol follows a publish-subscribe pattern that decouples the client that sends a message, which is the publisher, from the client or clients that receive the messages, which are the subscribers. Client connections are always handled by a MQTT broker, which is responsible for receiving and filtering the messages. Client connections are always handled by a MQTT broker, which is responsible for receiving and filtering the messages, determining who is subscribed to each message and sending them to them. So if we go back to the platform and enter any of the things that we have already created and select the interfaces section, you will see that here we have some credentials for both the HTTP and the MQTT method. So Altair SmartWorks IoT uses the OAuth protocol to authenticate and authorize the user. So authentication will check if the entity that has requested the action is truly that person. And authorization will check if the entity that has requested the action has the permissions to access there. So in MQTT, as we've seen before, it is the broker the one that makes its authorization and authentication process. But both in HTTP and MQTT, we need some kind of credentials to complete this process. and that is what we call the client ID and client secret. But in both cases, we need some kind of credentials to complete these processes. So in the case of MQTT, we will use the username and the password to identify ourselves before the broker. And in case of using HTTP, the client ID and client secret will generate a token that will be the authorization key. So in HTTP, you just have to copy the client ID and click over here to reset a client secret. Client secret will just be shown once, so if you need the value, just store it anywhere. For the MQTT credentials, you can choose the platform to auto-generate them for you by switching auto-generate to on and click on save. But you can also enter your own username and password and click on save. So as you can see over here, we have different options. So first thing we can do is to send some data to the properties. So here we can just be storing one value. But if we want to store historical data, we can send the data to the raw history section. So let's use again the API inspector to see how can we send data to the raw history section. In order to know what is the request that we should be making, let's go back to the API documentation and in real time check for the operations with data. As we want to create data, we just have to make a post request to this endpoint. So let's add data here, choose to post. We need to go to the authorization section and enter the client ID and client secret so that we know where do we want this data to be fit in. And then enter the scope that we want. In this case, a scope will be data.create. Click here to get the token. So now let's move on to the body section and see that we can send any type of message. So for example, let's try in test. If we refresh, we will have received the data over here. But we can also send it in JSON formatting. Remember to revoke the token that we have generated into this request if you are not going to use it anymore. So let's move on to see now how can we update the properties. Let's go back to AnythingDB section and search for the properties. So we should be making a put request to an endpoint similar like this one, and we need to put the properties as the payload. So we've seen an example on how HTTP protocol works, but in the utility belt we can also access MQTT inspector. So as I've mentioned before, SmartWorks IoT has its own MQTT broker, so that any message that we receive in the platform, it's republished using MQTT protocol. So if I try to change one of the properties, for example, So if I move back to the MQTT inspector, you've seen that I've received a message in the battery property. So MQTT inspector allows you to see MQTT incoming topics and messages and the format of the data payload. So a list of messages and topics is so you will know what topics are available. By default, you are subscribed to all the topics on the space, but if you click over here, you can filter to be subscribed to a certain topic. This way, when we have a real implementation and we start receiving data from the different sensors every specific set amount of time, we can go over here and check for the last messages received. We can see the history of messages. We can see the timestamp and also choose to increase the limit. If we want to subscribe to this topic, we can just copy it over here, choose the MQTT subscriptions, and choose to add the topic. That way we will just be looking at these messages. Similarly, we can interact with the actions. So for example, we have defined here an action to turn the AC system on off, and another action to turn the lights on off. So let's make the request for an action to turn the AC system on. Open the API inspector, choose post as the HTTP method, enter the following endpoint, and the following body structure. As you can see over here, the action has an input name turn type string. So with all this said, let's click on send. And as you can see, the action is queued with the status pending. So see how our actions appear over here. From here, you can change the time request format and also choose to delete some values if you want to clean the action call history. In a real implementation, after requesting this action, the device will make some changes so that the lights will turn on. Next thing we are going to do is to add a link to establish a relationship between this track and its owner. Now, if we click over here, we will get redirected to this specific user. So if you automate up these processes of creating new things and sending data, you can start to fill your database with all the information that you want. So from here, we are able to apply some filters to the different properties that we have. So for example, if we want just to display the things that have a parity level below 50%. And from all that tracks, the ones that are colored black. If we want to remove all the filters applied, we can click over here. From this button, we can also choose what colors we want to display or hide. And we can also reorganize the columns. Remember that if at any point you want to go back to show the different links for documentation and video, just click over here. And you can re-enable the hints, but also access the documentation. Now that we have all the data stored in AnythingDB, let's move on to implement some business logic about all the data that we are storing. So for doing that, we have the functions module. Functions provide the capability to execute custom business rules at any level, cloud and edge. They are divided into two main parts, workers and triggers. A worker is the function itself. It allows you to create custom-based functions written in Go and Python, so that you are able to implement machine learning models, predict future values, and also help when developing digital twin models and simulation processes. Functions will also help you to easily scale, and they are accessible through an API. Then we have the triggers, that are capable of invoking the serverless functions from an event source. Triggers works as listeners to a particular endpoint, capturing events and messages from different sources and redirecting them to one or more functions. So we have MQTT triggers that connects to an MQTT broker and create a subscription to one or more topics. When a message is received, the trigger will compare the topic of that message with the topics configured in the functions, and all the matching functions will be invoked. We also have cron triggers that allows you to schedule when to invoke a function. And finally, to help with all this, we have function logging implemented to know what is happening during the execution of a function. So let's go back to the platform and start to implement some custom business rules. So first thing we need to do is to go over here and click on New Worker. First function that we are going to create is going to generate an event whenever the battery level goes below a certain value. So let's name our function. Note that you can also add a description. Here you can choose between Go and Python. So let's choose Go for our first example. See how a default template is provided for each of the languages. Let's add our code over here. And now that we have our code, the next thing we need to do is to define the event trigger, so that we know when we want this function to be invoked. And let's click on Save. See how the status of the function is on pending. See how after a few seconds the status has changed to building. And finally, it will get to running. Note that this process might take a few minutes. While this process continues, let's move on to create our trigger. So for doing that, we have to go over here and click New Trigger. We can write a description, and we can choose between MQTT and cron trigger. As we are going to be using SmartWorks MQTT broker, let's just type here the host. If you remember before, we were using the username and the password that we get for each of the specific things. But for this use case, we may want that the function affects to every track that we have defined. So for doing that, we have to create labels. Labels enable to categorize entities such as things into customer-defined tags. And the good things about labels is that they have their own MQTT credentials. So if we assign a label to every track that we want to be assigned to this function invocation, then we can use the MQTT credentials of that label over here. So let's move on and define first our label. Let's give a name to it. As always, we can also add a description and we can customize the color. Click on Create, and if we select the security pane, we can generate the MQTT credentials over here. Similarly to things, we can choose to auto-generate them or write our own credentials. Now that we have the username and password defined, we just have to add here the topic, which is going to be the same as the one that we have assigned to our worker. So let's copy it. So if we take a look at this topic, what it means is that it is subscribed into this space to all the things inside the collection track that have assigned this label, which is the label ID of the one that we have created before. And in this case, it's going to be listening to the property battery. So let's click on Save. See how the process of creating a trigger just takes a few seconds. So let's go back to the workers section to check our function. So from here we can review the code and make any necessary changes, and also use the test pane if we want to check that our function is working as expected. But in this case, we are going to test it directly in the AnythingDB section to see if it works fine. So let's go back to the AnythingDB section. First thing we need to do is to add the label to all the things. See how from here we can start adding the labels and also create new labels if needed. But to visit this process, we can go over here and select all the things and click on Edit, Labels, and choose to add this label to all the things. When we click on Add, the label will be assigned to all the things. Similarly, we can choose to remove any label. So for example, if we select all the things and go back to Edit Labels, we can choose to remove this label to those things that have it assigned. In this case, it would be just this one. So if we just click on any of these things and assign a low value to the battery, let's see how the event gets created. Let's go back to the function section to create another function. See how labels can also be assigned here. For example, to identify which is the label that you have assigned to the things that are under the invocation of this function. Next function that we are going to create is going to update the state of our track depending on the total miles. So let's name our function. Note that there are also some restrictions regarding the function's name. And let's choose Python. Let's copy our code and also the trigger needed. As you can see, we are adding a similar topic. We just have to change the label's ID. So for this use case, we are going to create another label. So let's copy the ID of this label and add it over here. So now we will be listening to the property total miles of all the tracks inside the collection tracks that have this label assigned. And let's click on Save. Similarly, let's create the trigger for this function. Note that here we can also choose the quality of service level. The quality of service is an agreement between the sender of a message and the receiver of a message that defines the guarantee of a delivery for a specific message. So for example, we can change it to 1. This means that the message is always delivered at least once. Now that our function is running, let's assign the corresponding label and check if it is working. In this case, let's just choose to assign this label to certain tracks. So let's test this function. Let's also open the function log. Function log can be accessed clicking on the utility bell function log. And here we can choose between all the functions that we have created. So if we increase this value, we will see how the state changes and indicates that service is needed. And if we refresh here, we will see that it was correctly created. We have also a search bar to look for a specific value. By now, the application is almost ready, as we have the data stored and the business logic implemented. So let's say we want to accelerate the development process by inviting our colleagues to this space so that they can collaborate on the project. But at the same time, we will want to ensure that the different users have the right level of access to different entities in the platform. So for managing all this, we have the access control section. Access control allows you to set authorization rules, called policies, for every piece of your IoT platform. With them, you can set boundaries on what a user or client can do with a specific space. By grouping these policies, we can define roles and create flexible and reusable authorization rules to give or deny permissions to each subject. So we can manage the permissions on the devices that link SmartWorks IoT to external sources of information, to apply security restrictions, or create authorization code applications and client credentials applications to interact through the API. We can also have an overview of the users that have access to the SmartWorks Studio interface or through an end-user application. And as we were expecting, we can invite our colleagues and manage what they can create, read, update, or delete inside the platform. So let's move on to the access control section. From here, we can invite new users to add to our space. Just click here to invite the user, enter the email, and assign a role to this new user. By default, the role root is created, so let's choose this one for this example. Then, just send the invitation. If you need to resend the invitation email, just go over here and click Resend Invitation. So this is how the invitation email looks like. And by clicking over here, they can create a new account if they don't have one, or log in. So this is how receiving an invitation looks like. From here, the user can choose between rejecting or accepting the invitation. Whenever they accept it, they will see the space card, similar as we can see it. They can enter the space, and as they are root role, they can do and access everything in the platform. See how the status of the invitation has changed to active now that the user has accepted. But let's move on to create a new role and restrict the access to some of the users. As you can see here, we have the rule root that is created by default and that allows its subjects to do everything in the platform. So let's create a new role so that the users are able to view but not delete anything in the platform. So for doing that, just name the role. So we are not going to allow them to delete any of the resources inside AnythingDB or data, neither labels and functions. And also the MQTT credentials. And we are going to restrict the access to edge ops and authorization. So let's just click on Save. So let's see what happens when we assign the rule viewer to a user. So for doing that, we are just going to change the role to this one, from root to viewer. So now if they try to delete a resource from here, they won't be able. And same if they try to access something from edge ops. And same if they try to access the users, roles, or apps. An error message saying that the access credentials are not sufficient will be displayed. Last thing we have inside the access control section are the apps. So applications are ways to link SmartWorks IoT to external sources of information. These external sources must supply SmartWorks IoT with an access token before being able to communicate. So apps will help to define the permissions for those access tokens and then create them to be used externally. So for example, before, when we were storing our database with all the information, we use an application so that we can send the data to the multiple things inside a collection. So let's create an application so that we can later on access the information inside the SmartWorks IoT from Panopticon. So for doing that, just go over here and click on New App, name it, write a description if needed, and add the scopes required. Note that at least one scope is required. Here we can choose between two types of applications, client credentials and authorization code. Client credentials are a mechanism to generate an access token to use the API. So this is typically used when wanting to authenticate devices, serverless functions, and ECP clusters. So let's click on Save. But before closing this application, we need to enter a policy. So in this case, we are just allowing to do everything. Click on Save, and see how the security information is now displayed similarly to AnythingDB section. So from here you can copy the client ID, and if you want to get the client secret, just click on Reset Client Secret. Remember to store this information if you want to reuse it later. If you want to authenticate the users of a web or mobile application that has been built using SmartWorks IoT, you can also create an app. But in this case, the application should be type authorization code. So with this grant type, users can be authenticating without exposing a client secret in the app code. Instead, users can authenticate by entering a username and password in the SmartWorks IoT Identity Management Provider to retrieve an authorization code which can be exchanged for an access token. So to create this app, you just have to fill the following gaps. First one indicates where the user will be redirected once authenticated. The post-logout redirect URIs indicates where the user will be redirected after logging out. The front channel and back channel logout URI indicates the URI that supports the front channel logout mechanism and the application logout. And finally, the allowed CORS origins indicates the domains that are allowed to access the IDP. After filling all the information, you also have to enter a policy and click on Save. And similarly, the security information will be displayed. So by now, we are almost ready. Last thing we need to do is to create our dashboard. Real-time visualization offers down to the second data, automatically updating charts using multiple types of connectors. With this solution, you can see the data how you want, where you want, and fast enough to act quickly. This tool is powered by Altair Panopticon and supports a wide range of information visualization, including tree maps, heat maps, scatter plots, horizon graphs, and a wide range of other great visualization designed for fast comprehension and easy interpretation of static, time series, real-time streaming, and historic datasets. So Panopticon can access by clicking on Real-Time Visualization Workbooks. Every user has its own root folder created by default. So by right-clicking over it, you can rename your folder, create new folders, and choose if you want other users to access your folder. You can also choose to add a new workbook to that folder, to upload a workbook if someone has shared one with you, also edit the permissions of your root folder, and decided to import a bundle if someone has shared one with you. So let's rename this workbook and use it as our dashboard. Click on Edit, and first thing we need to do is to add a data table so that we can get the information from AnythingDB. By clicking over here, you have some templates predefined that will help you to get the data. In this case, we are going to choose Things Status Connector, as we want to get the information inside a collection. So only changes we need to make is to enter our own app credentials, and for doing that, we can reuse the application that we have created before. And enter here our space ID and the collection name. Click on Generate Columns, click on Refresh Preview, and you'll get all the information that we have stored over there. Click on Save, and let's go back. So now that we have some information here, we can start designing things on the dashboard part. So just draw a square the size of your visualization and see how the visualization menu displays. So to add one of these visualizations, simply click over it and start filling the needed information. So in this case, we are going to plot the battery that is going to represent the y-axis, and we want to plot it for the different items that will be the UIDs. Let's resize our visualization. We can keep on customizing our visualization. For example, we can choose the total kilometers to be the property representing the different colors. We can also customize the colors from here and make any other necessary changes. So we can order them by height, and also choose to add a title. Let's click on Save. So see how easy it is to create a dashboard. You can move to the View mode. You can export your report as a PDF. And you can zoom in to see the data in more detail, or even change to just see the data. Also, you can download Excel reports from here. So if you keep on adding more visualizations, you can end up having something like this. Here we have a real-time implementation on how the drivers are behaving. See how here the information of each one of the drivers keeps on updating? And see how we can also analyze the relation between different parameters such as the time and the distance, analyze the driver's behavior based on the hash breaking, and analyze the measured distance versus the calculated distance. So if we click over here to see the information of this specific driver, the information of Albi Mitchell will be displayed. We can change this limit to see how many times they had driven above this limit, analyze the route, and also the speed and the distance history. From here we can also check the status of its vehicle. If we move on to the fleet analysis, we can have an overview of the different companies and how the models are behaving. We can see the relation between the maintenance cost and the different models, see the incident that we have, and change from one company to another. So finally, if we get to have our mobile or web application, this is how we can interact with SmartWorks IoT. Imagine we let our users turn the light on and off and set the temperature in advance. See how we have a value of 25 registered in SmartWorks, and as soon as we change it from the app and we click to set it, it gets updated so that we can later perform analysis with that information. Similarly, if we choose to turn the lights off, see how the request is sent and received in SmartWorks IoT. So remember how before we define a function so that depending on the value of total miles, the state property will get updated. So that if we have a low value, the state will change to OK. This kind of information is the one that we can be sharing with the users through the application, so that they know the status of the truck on real time. See how in less than an hour we were able to create our IoT ecosystem and develop our smart connected product. So if you want to keep on learning, access our documentation and tutorials, enjoy the global evolution towards a smart connected everything.